Right, yeah, welcome back again to another section on this machine learning classes. We are looking at feature engineering at this point, and we want to start by looking at selection and extraction of features. Okay, so the concept of feature engineering is actually the process of selecting, creating, and transforming features from the available data that can enhance the performance and accuracy of machine learning models. It involves the combination of domain knowledge, statistical techniques, and creativity to derive valuable insights from data. Now, many people actually perform machine learning modeling, but do not understand even the difference between feature selection and feature extraction. Most times they interchange some of them because there's no understanding, and we don't know sometimes the steps in selecting features and extracting features. So this particular class we unveil to us what is feature selection and extraction, and what type do we have, and how do we go about it. All right, so feature selection actually is an important step in machine learning that involves selecting a subset of the available features to improve the performance of the model. Meanwhile, feature extraction is often used to create new features in image processing, speech recognition, natural language processing, and other applications where the raw data is high dimensional and difficult to work with. Now, you must understand that both techniques aim to reduce dimensionality and improve model performance, but they work in a fundamentally different ways. Okay, feature selection actually extracts features. Okay, from select a subset of features from original features, right? While feature extraction creates new features from original data. You can see the difference between the two now. Feature selection extracts features from just a subset from the original one, while feature extraction creates new features from the original one. So in feature selection, there is no creation of new features. You only extract from the best feature from the original features and drop the rest, while feature extraction use the original feature to create new features. So feature selection preserves original features. No transformation required. While feature extraction transforms data into new dimensions. So in interpretability, we have high feature selection is high. Feature high in feature selection. As you say, interpretability is high in feature selection, because it keeps the original meaning. While it is low in feature extraction because new features may not be intuitive. All right. So the methods are not the same. We have example of feature selection methods. We have filter methods such as correlation, and the rest of them. We have wrapper methods. We have embedded methods, and they also have feature extraction methods such as PCA, SVD, also encoder, and so on. Okay, so for cost, generally lower in feature selection, while often higher in extraction because it requires transformation of data. So use feature selection when original features are meaningful. You don't want to lose them. And use feature extraction when relationships between features matter. Right. So let's look at it a little bit more detail. The goal is to choose for selection. The goal of selection is to choose the most relevant features from the original set. That's the goal of feature selection. To choose original relevant features from the original set. For, like I mentioned before, filter method, we use statistical measures such as correlation, mutual information. Sometimes we use F score. We also use wrapper methods We train model iteratively using recursive feature elimination. Also have embedded method which features are selected during model training. We have what they call L1 regularization in Lasso. So, for example, a data set, in a data set of 100 features, selecting the top 20 based on correlating with the target. So that is just feature selection. From 100 features, we're selecting the top 20 based on correlation, top 20 based on correlation with targets. So the target. So we also have feature extraction. The goal of that is to create new features by combining or transforming original sets. Okay, so the approach could be linear methods such as PCA, SVD, LDA, and we also have which is a reduced dimension while preserving variances. Okay, we have nonlinear, which is TSNE, coders for complex patterns. So, for example, now converting 100 features into 10 PCA or 10 pieces via PCA method. Okay, so we can have a lot of features now, and the feature can be reduced to principal components like maybe 10 pieces, which becomes new features. All right, from 100 features. So that is just a concept now. If you look at this simple chart here, we are seeing that this is a feature selection, right? I mean, so the feature extraction, feature selection. What happens in selection here is that you can see all these, they remain the same, but we are taking red, we are taking green, we are taking blue, and taking a deep blue, okay, and this light blue and this blue, we are taking them while we are discarding the rest of the features. So with those features, they still remain, nothing happened to them, but we are taking only those features that are relevant among them. All right. So, but in a feature extraction here, we are trying to perform using a kind of statistical modeling to create new features from original features. For example, you can take when we take some feature here. So all of them, we bring them into a model and we try to process it to form new features, all right? Either mathematically or programmatically. So you can see we form new features here. You can see the new feature we form. So this feature we have formed, the color here, none of them are here. They are totally different from the color we have in here. Can you see? So this one shows that these features are new. They are all new. So which means this one, while this one, they are the same. Okay, the same feature. But we just discard the rest because these are the highly relevant features. But here we create new features from the original set. So now, advantages and the advantage of the feature selection is that it preserves interpretability, which means it retains original features, keeping model decision transparent. It reduces overfitting, eliminates irrelevant features, improving generalization, faster training, fewer features, speed up model computation, and reduce resource usage, simplifies models, create more efficient models by focusing on key variables. So, but you have to have some kind of demerit. It may lose interactions, ignores potential synergies between discarded features, because sometimes some of them they are interwoven. So for some features, they won't depend on another. So when you do away with some of them, you may lose some kind of synergies, interaction between them. And the base biased by method result depend heavily on the selection technique. For example, filter, wrapper, and embedded. Not for redundant data. Struggles when features are highly correlated, no transformation. And the threshold sensitivity performance hinges on choosing the right number of features. So then we also have advantage and disadvantage of feature extraction. One, it reduces dimensionality as a first advantage, transform data into fewer or more meaningful features for easier analysis, improve performance, enhance machine learning model accuracy by capturing essential patterns in the data. Feature selection, identify and retain the most informative features for modeling, and you do filter out irrelevant or redundant features, improving data quality, which is noise reduction. And also you have to touch on the other side, which is demerit, and which means loss of information. critical detail may be discarded during dimensional introduction. This is common sometimes in such that initially in PCA, sometimes you lose some little information that are necessary sometimes. So forfeiting risk, complex transformation can lead to models that don't generalize well. A computational course can be resource intensive for large data sets or deep learning methods. Requires expertise and effective feature extraction. Demands domain knowledge to select optimum transformation. In summary now, feature selection, one, choosing the best columns for your data set. The best column, that's it. In summary, for extraction, creating new columns for existing data from existing data. So that is just summary of the. So the trade-off here is that feature selection is more interpretable, while extraction often yields better performance for complex data. The choice depends on the problem's needs. So depend on what we are solving and what we are working with. So you may just need to, if for a very simple data set, we just need to do some kind of selection of features. Then we are good to go. But from kind of complex analysis, we may need to do some kind of a feature extraction by bringing out new features from the original set, and that is how we move on. So this is just what you need to understand. Know first before you go into machine learning proper. You must understand feature selection and extraction. So we are going to be looking at a practical implementation of feature selection methods in the next class while we continue in this training. So thank you so much for listening. I will see you in the next class. See you later.